Hi guys, sorry guys. Sorry for the 10 minutes delay, guys. Okay. I'm not going to switch on the video for a little while. Okay. After 10 minutes, I'll switch it on. How was the homework, guys?
It was good, Auntie.
What
easy.
Ashwik, I saw yours. For the others, I did not see several of your homework. How did you get?
I uploaded it today because didn't get a chance to do it over the week. I had done it today.
Okay, several of you have not done it, meaning it's not one, not two, right? Many of you have not done your homework, right? Okay, and on another note, I had administered some tests for the Algebra 1 class. Can I give the same test to you all, guys? Can I give the same test to you all as well? Should I add it in or no? Because you are also having your own homework, right? So I wanted to ask you whether if I administer, will you guys be taking it or not? Let me know, guys. Okay, let's see. Any questions on the last week's homework, guys?
Yeah, I had a question.
Yes, please. What number, what question?
On the PSAT mixed practice one,
Yeah.
for the geometry section, for question 2 on the geometry one for part B in the PSAT thing.
I don't know one.
Let me open it. Can I open it?
Yeah, me?
I'll open it, ma.
Yeah, okay, yeah, okay.
I'll open it. I'll switch on my video in 10 minutes, okay?
All right.
Layoffs, algebra. I'll open it. Wait. Was there a key mistake, Johan?
For what? The question?
No. Was there a key, meaning, was there an answer key that was incorrect? Is that what you want to show me?
No, I think the question didn't make sense to me.
Okay. Maybe. Tell me.
Yeah,
Which
me
one?
too.
I tried to screen through it, but looks like it did not. Let's see. But I would like to know what question where. We'll see. Which one, ma?
It was on the geometry section.
Mm-hmm.
It was question 2.
Question 2, huh? ABC. Let's do it together and see. AB equal to BC. AB equal to BC. I didn't do it. Personally, I did not do it and then give it to you. But I did screen through. AB equal to BC. Extend CB past B. Extend CB past B to D. BC is 35. BCA is 35. CBD.
Yeah, because it was a straight line.
Okay, yeah. CBD is 45. What is ABD? B is 110. B is 110. Who said B is 110? Okay. Definitely the problem has an error. Skip B2, ma. Johan, skip B2. I'm sorry about it. Thanks for letting me know. Definitely B2 has an issue. Okay, any other questions?
I'm fine.
Okay, this was good. Exponential function intercepts you were able to do?
Yeah.
Okay, and linear models were good?
Mm-hmm.
Good to know. But my main learning from this set is only this for you guys. Okay, this one everybody had doubts on last week, right? I hope you all understood when there is a percentage increase, decrease, how to calculate it. Okay, that's a common question that comes. Can I move on?
Yes.
Okay, now let's go to the other stuff, guys. Oh, okay, you're all factoring quadratic expressions. Okay. Okay. I wanted to show a couple of things. I'm not going to go to the book yet. Okay, book has it in a very different way. Okay, I also want to show you several things. Now, you know how to factor trinomials from last week, right? If you get 2x squared plus 5x plus 3, so you're just going to factor it out, meaning you will find two numbers whose product is 6 and whose sum is 5. So that way we found out 3, 2. So you're going to split this as 3x, 2x plus 3. This is going to be 2x squared plus. Now, if I take out x is common, This is going to be 2x plus 3 and 1 is common. This is going to be 2x plus 3. Now 2x is going to come. This sort of factoring is trinomial factoring. This is a trinomial, right? Now, this is x plus 1. This you all know, right? But there are other ways of factoring quadratics as well. Okay. The book dives deep into a lot of things, but before moving on to that depth, right, I also want you to solve these using quadratic formula. In the sense, how many of you know quadratic formula? A couple of ways I'm going to show you. The same 10 problems can be done in so many different ways. Okay. So, number one, trinomial factoring, you all understood what it is. Sum of roots, product of roots. That you guys understood. But I really want you to understand using the formula. Before I go here, right, Vishnu Ram, very good job on your homework, Vishnu Ram. I really loved the way you had shown the homework.
Okay.
One of the
Thank you.
best homeworks I've ever seen, meaning very nice presenting this time. That is the way I want homework to be done. Okay. It was very good. Meaning showing the entirety of what you did when you did the homework was very good from his end. Okay. So now we did factoring trinomials, right? So I would like you to understand how to factor quadratics using quadratic formula number 2. Okay, the first one was trinomial factoring. Third one is completing squares. Okay, both the things is going to do the same thing. Okay, the same problems you're going to solve. You can say, Auntie, I know how to do the other one. I don't need to learn this quadratic formula. No. Suppose if you're not able to find those two numbers whose product is 6 and whose sum is 5, the best thing would be to use your quadratic formula. So let me say the standard form of a quadratic equation is ax squared plus bx plus c. Ashwin, did you get a chance to do the homework, Amma? Or am missing something?
Yeah, I think I did all the homework.
You submitted them, then I did not see honestly yours. Okay.
Yeah,
Swara, what, Amma?
I'm pretty sure I submitted that.
Okay, okay. No. You might have submitted it, but I honestly currently don't remember. Ashwik, I saw everybody else. Sham, how are you doing, Sham, with respect to homework and all?
Good.
Did you submit it?
Yes. I
Why?
think so.
I sincerely don't remember Ashwin's and Sham's. Let me see. Ritisha, did you? Oh, yeah. You are going to submit it after class, you said, right?
No, I submitted it. I was only able to do it like today because I didn't have time over the week.
No problem at all. So after you submitted, then I did not go through. Okay, let's see.
Yeah.
Ax squared plus bx plus c is the standard form of a quadratic equation, right? Okay. Now, if I'm giving you this 2x squared plus 5x plus c plus 3, do you know how to plot it in a graph, guys? How many of you can plot it in a graph? Can you plot it in a graph? Yes, no, please tell me. You can't. Why? It's a relationship between y and x. You know how to plot this line nicely.
Isn't
The
it ax by plus c? Or is it both?
ax squared plus
Plus
bx plus
bx?
c equal to
Okay.
y.
Okay.
You see what I mean? This is a linear function. This is a linear function. This is a quadratic function. You got it? You understood? This is a linear function. This is a quadratic function. So now you all know how to graph this, right? Y equal to 2x plus 3, you all know how to graph this, right? You know, then what is the problem with this? Y equal to, let me see. Now we are going to do number 2, okay? Y equal to 2x squared plus 5x plus c. Would you be able to graph it or no?
Should
Would
I?
you be,
Yeah.
Isn't it like a problem?
tell me how will you graph it?
It becomes a parabola, right?
It becomes a parabola, but how will you graph it? Can you tell me?
It's downward.
Will it be downward, you think?
Yeah.
Why would it be downward? What tells you that it will be downward? I never taught you anything, but anyway, if you know, I'm happy. But how is it downward? Why is
Because
it
like
downward? Huh?
A
Can you try what? Yeah, Ashwik, go ahead and say.
Isn't a like greater than 0, so it goes down?
Doesn't it go up?
Good thoughts, Ashwik, but
But
a good try. Okay, I can't say that's right. Go ahead.
doesn't it go up?
It goes up. Definitely it goes up. But how will you graph it? See, it is just xy, two variables, two different quantities. You're going to substitute your own values for the independent variable and find out what is the dependent variable and graph it, right? So can I,
Maybe minus 3 equals 2x squared plus 5x.
what do you mean by that? I don't get
Like,
you.
would you minus 3 on both sides? Or like,
Okay.
or y equals minus 3?
I want to show you. Hold on. Let me show you graphing, okay? Yeah, let me show you the graph. 1 second, guys. Yeah, 1 second, guys. Good enough? Okay, now let me put on the video too. Here we go. When you think about it, right, x is your independent variable. In this as well, what did you do? 2x minus 3. How did you graph it? You put in your own values for x, right? Minus 1, 0, 1, 2 negative values, 2 positive values. So now y value, plug in minus 2 and see. This will be minus 7. Plug in minus 1 and see. Minus 5. Plug in 0, minus 3. Plug in 1, 1. Plug in 2. Plug in 1, I'm sorry, minus 1. Plug in 2. So 1. This is how you plotted this in a graph. Same thing applies here, guys. If you want to do that, x, y, same thing you can do here. See, the thing is, only thing is, I don't know whether we'll get both parts of the graph. Let's see. How about, let me consider minus 5, minus 3, minus 2, 0, 2, 3, 5. Let me go a little farther on both sides. Okay. If I do that, if I put in minus 5, what happens? If I put in minus 5, 25 times 2, 50. 50 minus 25 is 25, plus 3, 28. Then if you put in a minus 3, 9 times 2 is 18. 18 minus 15, 18 minus 15 is a 3. 3 plus 3 is a 6. Then if I put in minus 2, 4 2s are 8. 8 minus 10 is a minus 2. Minus 2 plus 3 is a 1. Put in 0, answer is a 3. Put in 2, 4 2s are 8. 8 plus 10 plus 3 is 18, 19, 20, 21. Put in 3, 9 2s are 18 plus 15 plus 3 is 18 plus 18 is a 36. It goes up. I don't need that. Okay. Now if I plot it, minus 5 is a 28, minus 3. Minus 3 is a 6, minus 2 is a 1, 0. Minus 2 is a 1, 0 is a 3 again. See? And then 0 is a 3. So it goes here. 0 is a 3. So it is symmetric about what? 0 is a 3, huh? Yeah, 0 is a 3. Okay, and then 2 is a 21. So it goes like this. You see the curve? Do you see the curve? It's again a parabola facing up. Ashwik, to answer your question, right, Ashwik? I don't want to get you there right away, but since you brought it up, right, Ashwik? If there is a negative sign in front of the highest power of x, right, then it will be a downward facing parabola. Make sense?
Okay, yeah.
Yeah, so then that you don't need to know now, but since you brought it up, I just talked to you about it, okay? So this is how you go ahead and plot anything given, you will be able to find out what the graph is, how the graph is using this tactus. Okay, you can put in your own independent variables, find out the dependent variable and then graph it. Ashwin, what are they doing in school?
In school,
Uh-huh.
we're learning about like arithmetic and geometry sequences. I think we just had a test on it.
Is it easy?
Yeah.
Okay, guys, I really wanted to understand. In my Algebra 1 class, I know that I have not covered arithmetic geometric sequences, okay? But I gave them, meaning in this class, I have not covered. But as a part of my school-based algebra class, right, I covered arithmetic geometric sequences, okay? Second thing is, uh, different types, different forms of linear equations. Can I assign both the tests to you or you don't need? Please raise your hands if you would like to attend the tests on all these different forms of linear equations. Shall I assign the test or you don't want? I am absolutely fine. I respect whatever you want. But can you raise your hand if you want so that I'll know majority of you what do you want? That's all. Shall I assign that test to your class?
Yeah, fine.
You're fine doing it? Okay. Who doesn't want it? I'm not pressurizing, guys. If you would like to take the test and see where you are and develop, it's fine. If you already know it, I respect it. So please raise your hand if you want to, if you want me to assign those tests in this class as well. Ritisha wants, okay. Raise now, please do it using the react button, right? It's easier.
Fourth.
Is it?
Meltdown Madness, we were fourth.
Okay, you all don't want, huh?
Wait, Auntie,
Mm.
will we do it during the class or as homework?
At home. If I get you during class, the class time will go, right? Super. Okay, okay, I'm just checking. Okay, some of you need it. Okay. Okay, Ashwin said he's okay. Ashwin, okay. Johan, you're getting overwhelmed, huh?
I mean, I'm okay.
A lot of okay. No, I respect it, Johan. No problem at all. You can be as plain as it can be. Okay, that's fine. I'll go ahead and allocate it, but then if you don't want to skip it, okay? Okay. Now let's go ahead. Yeah, I saw Ma. You can get off your hands. I don't know what you guys' activities are into, right? So I respect whatever you want, we'll do, okay? So when I see the test, right, even if you have not attended, I won't be bothered. You get it? That is why I asked to understand, okay? Some of you raised your hand, so if you didn't attempt, then I will come at the back of you. 2x square plus 5x plus 3. Now this is of the format ax square plus bx plus c. Ax square plus bx plus c. Now the quadratic formula says how to find out x here. You don't need to factor out anything. Okay, you can just plug into the formula minus b plus or minus b square minus 4ac by 2a. How easy? You know what is b? What is b here? What is b here? 5 plus or minus, what is b square? 25 minus 4 times 2 times 3 divide by 2 times 2 minus 5 plus or minus 25 minus 24 divide by 4 minus 5 plus or minus 1 by 4. That gets you to minus 5 plus 1 by 4 or minus 5 minus 1 by 4. That gets you to minus 4 by 4 or minus 6 by 4, which is minus 1. X will be minus 1 or x will be equal to minus 3 by 2. Any questions, guys? That's the same thing you get when you factorize it. 2x square plus 3x plus 2x plus 3. I take out x as common, 2x plus 3. Then I take 1 as common, 2x plus 3. This gets you to x plus 1 times 2x plus 3. For me, from here, okay, you factorized it into product of linear factors. Okay. But when we did this, right, when we put this into a parabola, right, the parabola was something like this, right? Was something like what? Mm, this parabola was something like what we did not, it should have been like this. Minus 1, it should have cut the y-axis and then this is minus, this should have been like this. So minus 1, it cut it and then minus 2 by 3. It should have gone like this, minus 3 by 2. So basically, okay, what are these? Here, you're putting, let me go ahead and show you. To this one, you're placing it as y or the function f of x. Now think about y values are in this, x values are in this, correct? Now, if you plug in y equal to 0, what happens? The factorized product, right? 2x plus 3 and x plus 1. That factorized product, when you put y equal to 0, what do you get? For a linear equation, what do you get? In this case, 2x minus 3 equal to y. If I plug in y equal to 0, what is that you'll get, guys? What is that you'll get when you plug in y equal to 0?
3x equals 3 by 2.
That is true, but what will you get? What is that point called?
The x-intercept.
Exactly, x-intercept. If I plug in y equal to 0 here, what would I get again?
Y-intercept.
If you plug in x equal to 0, if you plug in y equal to 0, you get your x-intercept. Correct? I'm saying I'll plug in y equal to 0 here. What will I get still?
The x-intercept.
X-intercept. Now, some number times some number equal to 0 means, can I say, hey, this has to be 0? Can I say that? Or can I say this has to be 0? Can I say that? Suppose if a number times another number is 0, can I say that this is 0?
Yeah.
Or, yeah, I can say that. Or, suppose let's say I give this 5 to you. This is a box. Can I say that this is 0? That is called the zero product rule. This is called the zero product rule. Only when one of the number is 0, then their product can be 0. Now you equated y equal to 0. So one of them has to be 0. If one of them has to be 0, then I will say 2x plus 3 equal to 0. Right? Then x will be equal to minus 3 by 2. See? Suppose if I make this 0, x plus 1 equal to 0, you end up with x equal to minus 1. So we are very clear that y equal to 0 when x equal to minus 3 by 2 comma 0. Again, y equal to 0 when x equal to minus 1. What are these 2 points? These 2 points are called the
X-intercept.
x-intercepts of this graph. Now, how to plot them? Literally, minus 3 by 2 comma 0 and minus
1.
comma 0, minus 3 by 2. This is minus 1, this is minus 3 by 2. This is 1.5. So the graph cuts the x-axis at these 2 points. That is what it means. That's what we are trying to find out by factorizing it. Why do we want to factorize it? First, we wanted to express it as a product of linear factors. After factorizing, what did we do? We try to equate it to 0. Just like in a linear equation, we equated to 0 and found out one point, which was x-intercept. Here, if you equate it to 0, you will get the x-intercept. That is where factorization is needed for quadratics. One way of factorizing is factorizing the trinomial that you did last week. The second way is to use your quadratic formula. Why we are working with the quadratic formula right away? Because for me, you guys may appear for PSAT through soon, meaning it's not going to be another 1 year, right? So if you learn it now itself, right, you will be able to tackle any problem that comes in that. Okay, so quadratic formula is a one-stop solution for any factoring, whatever be the quadratic equation, right? Whether you know or whether your mind strikes to get what factors, what will be the two numbers that whose product will be this, sum will be this. Instead of thinking all that, you can blindly go for a quadratic equation of this type, right? Your x value, the x-intercept, right? I mean, the x-intercept, right? The x-intercept is what is this point? I mean, these are the points where the graph crosses the x-axis, right? That point will be given by minus b plus or minus b square minus 4ac, square root of b square minus 4ac by 2a. What was the question? Somebody had a question, Johan. Yes.
Can I go to the bathroom?
Yeah, please. Johan, tell me ma, what question?
So yeah, okay. So in the quadratic formula, you only get one answer though. Like even though there might be two x-intercepts. So how would you get like the other x-intercept with the quadratic formula?
I'll show you. This one is a one-stop solution, meaning you don't have to know any other type of quadratic factoring other than this at least for the exam sake, for the standardized exam sake, if you know this, that is more than enough. Because trinomial factoring, sometimes you won't, if these two numbers are hard, you will not be able to quickly find. It's all time based, right? Quickly finding the two numbers whose product is the product of 3 and 2 and the sum is this, it's going to take a while. But here it's monotonous, it's mechanical. You're just going to plug in values and you're going to get it. Johan, to answer your question, there is a plus or a minus here. Did you see that? So I will redo it. I did it, but I erased it, right? So I will redo it and make sure everybody understands. 5, if I plug in for B here, A equal to 2, B equal to 5, C equal to 3. You're just going to plug it in, minus 5. See, there is a plus or a minus. And then B square minus 4 times A times C, divide by 2 times 2. Any questions still here? Now minus 5 plus or minus square root of 1 by 4. Now Johan, see, it divides into 2. Minus 5 plus or minus 1 by 4. So this becomes minus 5 plus 1 by 4. Another one becomes minus 5 minus 1 by 4. Makes sense? There are 2. I divided into 2. This plus or minus, first time I executed with a plus, second time I executed with a minus. So this becomes minus 4 by 4 or minus 6 by 4. 2. Did you get it? It's not division or.
Yeah, okay, I get it now.
Yeah. So that is how it splits into 2. You get the same minus 1 and minus 3 by 2. Easy, right? So any quadratic equation can be factorized using this method. Okay. But there are so many things that we did not learn, guys. I am in a hurry to just make sure that you know how to factorize any quadratic given. And given any equation, whether it is linear or quadratic or exponential, whatever they give you, you should be able to graph them. Okay, suppose if I give you this equation, would you be able to graph it? Now that we learned quadratic formula, I'll give you 1 or 2 problems in it. Then you can go ahead and let's try 1 or 2.
I had a question.
Yes, please go ahead.
When you showed us like how to like do it, there was one where it said -5 plus or minus
Let me share this.
square root of 1
I think
and
I erased it.
-5 plus 1.
Let me see whether it will come back again. Let me see whether it will come back again. Give me a minute. Oh no. Okay, that's okay. Swarit, come again. Should I
was-
do this again?
Yeah, it was like -5
I can do
plus.
it. No, it won't take a minute. It won't take a time at all. Minus b plus or minus b square. Sorry, Swarit, it went off because I switched screen, right? 4ac by 2a. 4 minus 5 plus or minus square root of 1 by 4. What is that, Swarit?
How do you get like square root of 1 and also 1, like, or square root of 1 to 1? Like you said, from square root of 1 you did to -5 plus 1 and -5 minus 1.
Lemma. Please, I did not understand. Hold on. From this to this you're asking, or from this to this you're asking?
From the square root of 1 to the other two.
Ah, okay. Let me write it properly. After this, what I did, what is square root of 1?
Uh,
Square root of 1 is what, Amma? What times what is 1?
1. Okay.
Yes. So minus 5
Oh,
plus.
so you have to do both. -5 plus 1 and -5 minus 1.
Correct.
Okay.
Make sense?
Yeah.
Clear, huh?
What would happen if it's a non-squareable number?
Yeah, then it becomes okay. Let's go there. That's a good question. Okay, I was happy nobody asked about it. Okay, what happens if it is a non-squareable number? Okay, let me bring up a non-squareable number. Let's
Not
search.
like a negative, not like an imaginary number, but like.
Yeah, I got it. I'm going to search internet, get a non-squareable number. Okay, wait. Quadratic equation with irrational roots. Let's do that. Let's do one formula. One question on that, okay? See this, we have not gone into the book at all. It's okay, I feel, okay? Let's do this one. Let's do this one. Oh my gosh, what did I do? Oh, okay, let's do this. Let's take our, let's go to our thing. Notes, where is the notes? Oh my gosh. What, guys? 1 second, wait. What is copying here? Oh my gosh. 1 second, please. I thought I copied this. Huh. Okay, let's go ahead and try this one. So I'm going to do this like this. A equal to 2, B equal to 1, C equal to -7. So let's try this. Quadratic formula says B square minus 4.
I mean minus B
Yeah, correct.
plus or minus.
Yeah, there are so many things into it. Okay, I did not talk to you about anything. Okay, I just made your task easy. Minus B plus or minus B square minus 4AC divided by 2A. How easy, guys? Minus 1 plus or minus 7s are 4, 4s are 8, 7 8s are 56, right? Plus 56, so root 57. Now you get non-squareable number, right? Sorry,
Mhm.
what do? You tell me, meaning, what is this sort of a number? What is this number? What is this number? What type of number in the real number system is this?
Irrational.
Irrational.
You know,
You see? So the combination of this plus root 57 by 4, this one is minus 1 minus root 57 by 4. One thing what you understand is the roots, I don't know, the x value you put, right? X equal to, finally you find out x values, right? There should be two different values of x, right? That x value that you find out is called x-intercepts, or you can call it as roots, or you can call it as,
solutions.
what is solutions? What else?
I think this is 0, right? If I'm
Zeros, yeah. So many names it has, okay? The roots usually at your level, right, when you get started, right, it will always be a squareable number. You can have fun, but this one, this particular thing, right, whatever you're putting it inside this, right, this is called, what is that actually? This is actually b square minus 4ac, right? This b square minus 4ac is so significant. Okay, we are going to learn about it. This is called discriminant. Okay, this is
that like
called,
that term like where you
yeah,
can't you
that b
get
square minus 4ac from a quadratic equation is called discriminant. Okay, it has got such a lot of significance to it, meaning if you know the value of this b square minus 4ac in a quadratic function, right, you can really predict how the graph is going to be, where the graph is going to cut the x-axis, what are going to be the root solutions, whatever the type, the nature of the solutions, where it is going to cut the x-axis, how the graph is going to appear. Is it, see, the u can be here, can be here, can be here, can be here, can go through the x-axis, can be upside down, it can be anything. But knowing what the value of discriminant really opens the door for so many things. You can get to know about the entire function with this discriminant, that is b square minus 4ac. If you compute the value of this, okay, when the value can be either equal to 0 or less than 0 or greater than 0. There can be three different things for this. Whatever is inside the square root can be equal to 0. Then in that case, I'm going to get real repeated roots. Do you all know what is the difference between real and rational functions? Real and rational numbers. What is the difference between real and rational numbers? Yes, Ritisha. What is real? What is rational number? What is the difference? I
Oh,
know we studied this in
real includes irrational numbers as well.
Real has rational integers. Hold on.
let's go one by one. We need to really understand. Okay. Well, it can be rational, it can be irrational. Okay. Example of irrational function is, these are irrational. Do you all agree with me?
Yeah.
Coming to rational, what it can be?
2,
Two.
3 over 4.
We'll start with counting numbers. We'll start with counting numbers. These things don't forget, guys. Counting numbers. Counting numbers start with 1, 2, 3, 4, right? And then what is the next? In the circle, what is the next?
Whole.
Whole, correct. 0 gets added. Then what gets added?
Integers.
Integers, the negative gets added. And then
Rational.
rational. So the big circle is the rational. Okay, inside that you can have integers, whole numbers, and counting numbers. Okay, the other side is irrational. But something that does not belong to the real numbers is the imaginary numbers. Make sense, guys?
Mm-hmm.
Dia, are you following, ma?
Yeah.
Now, if I say real repeated roots, right? It can be real means it can be both rational and irrational. Make sense?
Yeah.
Okay, now if it is less than 0 means what happens? You tell me, what would happen?
The parabola will be like an upside down.
Mama, please, please, please. The b square, the discriminant is going to be less than 0. So what happens?
Be an imaginary number.
Exactly. You will get a square root of a negative number. Square root of a negative number, when it comes, the x values are going to be imaginary. I'll tell you one trick, okay? If the roots are imaginary, right? Imaginary means they are not going to touch the x-axis. That's what it means when graphing. If the roots are imaginary, then the parabola does not touch your x-axis. There is no real x value, okay, which can bring your y value to 0. Make sense? That it's just meaning I wanted you to learn slowly, but you will learn it when we go for graphing and all, okay? If it is greater than 0, what happens? It can be a perfect square. It need not be a perfect square. It can be a perfect square or it need not be, because see, whatever is inside, right? Like Swarit said, right? Can it not be a perfect square? So it can be a perfect square, not a perfect square. Two chances are there. Two different choices are there, right? When it is a perfect square, then the roots are, when it is a perfect square means it comes out of the radical, right? Right? In that case, it will be real distinct roots. Real rational. This will be rational too. Okay. Not a perfect square means what will you get? Real irrational roots. Basically, if there is a plus root 57, there will be a minus root 57. Irrational roots occur in pairs only. It will be the opposite. One will be plus, one will be minus. Make sense, guys?
Okay.
So this discriminant carries such a lot of weightage, okay? I don't want to stop here, okay? This is just an intro to discriminant I've given you, okay? Usually in Algebra 1 class, I do take one entire class detailing what is discriminant, how are these roots. We will solve different problems of this category, this category, this category. The discriminant definitely carries much more weightage than we are right now thinking, and it can be the theme of so many questions in standardized tests. Okay, so b square minus 4ac can really tell you the nature of roots. There are only three possibilities. One is equal to 0, less than 0, or greater than 0. Less than 0 is imaginary roots. Think about it. If this is going to be negative, what happens? Roots are going to be imaginary. But if that is going to be equal to 0, let's see. Okay. I'm going to rewrite this, guys, okay? Let's say discriminant. We are discussing the discriminant now, right? Discriminant. It can be 0, can be less than 0, can be greater than 0. Equal to 0 means real repeated roots. Okay. Less than 0 means imaginary roots. Imaginary roots occur in pairs. Okay. And irrational roots occur in pairs. Now this one can be a perfect square, need not be a perfect square. Any questions still here? Perfect square means rational distinct roots. Rational distinct roots. This one is irrational. Irrational distinct roots. Okay. Now, How about this? What do you think about the discriminant? Think about the discriminant. B square minus 4AC. What's up with this here? No, I want to do 4, guys. I'm sorry. I didn't want to 2. I didn't want a 2 there. Okay, I'm sorry. 4AC means this is a 4, right? 4AC. So that gets you to, I'm just calculating the discriminant, okay? That gets you to 16 minus 16, 0. So how will the roots of this be? What do you all think? It's going to be real repeated roots. What does that mean? Real repeated roots. Let's find out. Let's factorize and see. What number? How to split that? Can one of you tell me how to split it?
X and
X
is
X2, X plus 2.
2x.
2x plus 2, yeah.
Yeah. So take out x as common. X plus 2. Take out 2 as common. X plus 2 equal to 0. X plus 2, x plus 2 equal to 0. Ah, do you see? X equal to minus 2, x equal to minus 2. Do you see it?
Yeah.
That means when you graph it, minus 2 is the only point. Only point. So it is not going to cross the y-axis, but it is going to make a U-turn at the y-axis. That's what it means. You got it? For you to understand that little bit more, instead of just like that crookedly telling that's going to be the graph, let's do this and see. Okay, now let me try minus 5, minus 3, minus 2, minus 1, 0, 2. Let's do these graphs. This is my equation, right? I don't want to substitute here. Substituting here is easier, guys. When you look at it, substituting here is easier. Okay, substitute x equal to minus 5. That will become minus 3 times minus 3, which is 9. Substituting minus 3 for x, minus 1, which is 1. Substituting minus 2. See how easy it is to substitute in this equation than this. Don't do this in this. Substitute directly here. This is going to be 0 times 0, 0. Substitute 1, it's going to be 1. If you substitute 0, it's going to be 4. If you substitute 2, 16. When I graph it, right, minus 5 is a 9, minus 3 is a 1, minus 2 is a 0, and then minus 1 is a 1. Oh, it goes up. I see. It goes up. 0 is a 4. So you see, guys, here it goes, touches the x-axis, takes a U-turn. Usually how we have seen the parabola, we've seen the parabola go like this. Then that means the parabola cuts the x-axis at those 2 points. Last time what did we see? Minus 1 and minus 3 by 2. Those are the 2 points where it cut. And then it went down and went up. Now when it have repeated roots, it will touch the x-axis, take a U-turn and move up. That's what it means when it has repeated roots. Make sense? Now let's consider another one. How about this? So the discriminant has gotten a lot of value to it. That's what I wanted to say. How about this? How about this? X square plus 6x plus 9. What do you think it should be? Do you think it's by seeing this, can anyone tell me what type of root it will have? Yes, Ritisha.
Real repeated root.
Why do you think so?
Because when you do it, you'll get x plus 3x plus 3x plus 9.
Agree. X square plus 3x. See, it's repeating again. X plus 3 common. Now 3, take it out, x plus 3 common. Again, it results in repeated root. You see, repeated root means here, when you consider b square minus 4ac, let's consider b square discriminant. What happens?
Wouldn't x equal minus 3?
Yeah, x equal to minus 3. So what does that mean in a graph? The graph comes to minus 3 and takes a U-turn here. Make sense? Does that make sense, guys?
Yeah.
Ashwin, you're following, Ashwin?
Yeah.
So immediately, as soon as you see this, you can do b square minus 4ac and determine the type of roots. Discriminant has really good value. Meaning, we will do complicated problems with this. With your book, we will do complicated problems, okay? But I want you to know more about it. More, wait. How about this? How about this? Yeah. Okay. How about this, guys? Okay, you tell me. Okay, let me ask you. I don't know whether you'll be able to, but let's see. Let's see. I don't know from what I said. I don't think I have explained enough for you to do this. Let's see. What type of roots will this be? What type of roots will this graph get you? How will the discriminant be?
Equal to 0.
Yep, equal to 0. It is taking a U-turn on the x-axis, right? Good job. How about,
X equals 3, right?
what, ma?
X equals 3.
Correct. X equal to 3. Correct. It's a repeated root. Correct. Good job. This one? See, wait. If you're all going to guess the x value, I'll make it bigger, guys. How about this? How is this?
X is a little less than -1 and a little less than 3.
That's true. Yeah, but
So
what?
it's imaginary? Is it?
Really?
Or no, wait, no, it's not.
Hmm.
No, it's either perfect or non-perfect.
I think it's non-perfect.
Yeah, it is a non-perfect discriminant. Meaning non-perfect discriminant means it's greater than 0, not a perfect square.
X is -1 and 3.
No, it's a little less.
It is not a lattice point. Lattice point means you'll get like this. Like this, if you get it, it's a lattice point. If you get like this, it's not a lattice point, right?
Oh.
These are not these are called lattice points. Okay, these are not lattice points. Just get to know these definitions, guys. So here, if it is a lattice point, then it might be a perfect square. But here, your discriminant will not be a perfect square, but it will be greater than 0. Greater than just crossing the x-axis. Make sense? Okay, let's see. Good guys, meaning I thought you cannot say this. Nice to know. How about this? I'm just asking about the discriminant. How will the discriminant be?
X.
X. That's what. How will the discriminant be?
Equal to 0.
2.
Good. X equal to 0. No. Why is 0 at that point?
X is -2. Right?
X is -2. That's right. So what type of discriminant?
Um,
Only one time it is touching the x-axis and making a U-turn, right?
It's, what is it called? It's 0.
It is 0. Discriminant, yeah, sorry. Johan, did you mean discriminant is 0?
Yeah.
Sorry, yes. Discriminant is 0. Okay. Now one last question. Sham, are you following Sham? You're not answering. You want to keep quiet?
Yes, I'm following.
You're following. Good job. How about this? This will take couple of classes for me, guys. If
Is that irrational?
That's irrational.
irrational roots.
No.
Good. So the discriminant will be
Imaginary?
less than 0.
Yeah.
Discriminant will be less than 0. Okay, let's try some challenging problems. Okay, discriminant to determine. Okay, you will find the discriminant and the nature of roots. It's just plugging in. Discriminant, you're going to do b square minus 4ac. Okay, nature of roots, you'll find out. In a graph, now you know to find out. In an equation, you know to find out. Correct? Now, let me ask you this. Would you be able to tackle this problem? These are challenge problems. Would you be able to try that? We are going to do, oh my God. We can take another 10 minutes, guys, please. Okay, let's do this because we started late, right? Let's do all the 5 challenging problems. You'll be able to do this. You want me to? I would be happy to help. But if you want to try figure out, I am happy.
Oh, can you help?
Yeah. Could you?
Wait, can I try this?
And
Ask them my answer.
Any negative number, Amma. It's really, I don't know the answer. Let's see. Let's see. I can check. I don't have the solution, but I do have the answer. Let's do it together. Wait. I thought it can't be. Not really, Johan. Let's see. How did you get that? See, find all the values of a such that it has two real roots, right? When it will have real roots, the real roots are possible only when the discriminant is either equal to
0 or greater.
0 or it can be greater than 0, correct?
Yeah.
Has two real roots means it's not a repeated root. Okay, I can take this off, correct? When discriminant is greater than 0, na, b square minus 4ac. What is b? Let me not do that square. Discriminant is b square minus 4ac. So it will be 9 minus 4 times 5 times a, 9 minus 20a. So discriminant is 9 minus 28. Discriminant should be greater than 0. When I combine these two, 9 minus 20a is greater than 0. 9 is greater than 20a. A is less than 9 by 20. Let me check. Let me check once. Oh, that's right. Correct. A is less than 9 by 20. Does it make sense, guys?
Yeah.
Go ahead.
No, I get
Go ahead.
Wait,
Oh,
you would divide both sides by 20 and then
yeah, correct.
20 is greater than A.
Correct.
Okay.
Make sense?
Yeah.
Okay, good. Nice. Okay, like that, we'll solve one or two more problems. You'll be amazed at yourself. You'll be able to solve everything. You guys understand it very well. That's why I skipped a lot ahead and went to this. But after this, I'll come back to the book next week. Okay. Let's do this. See, this is a good one. It's just that you need to set up the inequality properly. Set up the inequality properly based on the discriminant. It's not hard. You know what? Can I help or you're working it out?
I'm working it out.
Others, if you need help immediately, let me know. I'll do it on the board quickly. We'll do max five problems. Second one we are on. Let's see.
I said my answer.
You sent your answer. Let me check my. Is it not? Is it? Oh, okay. I think you must be right on that. Correct. See, that's what you guys are picking up so fast. It's worth getting you this. It takes a couple of classes for me to get to these things. Let's see. Whoever completed the second one can go to the third one. This is the second one. So the third one will be an inequality. You see, the second one will be an equation. Yes, Swarit, that's right. That's right, Rutesha. That's a good amount of learning for this one class. Find all values of A such that love imaginary roots. Discriminant is so powerful. Ashwin, correct, ma. Ashwik, correct. I think all of you are on it. Okay, good. Nice. Shyam, correct. Vishnuram, did you check or did you need help? Yes, Madhya, correct.
No, I'm sending the answer.
Sure. But Ritisha, I see. I don't know. I don't know, Ritisha. I'm checking.
Yeah, I was gonna ask you to check. I
1 minute, Amma.
yeah,
23.
of course.
What number did I give you? 23. Um. You did not simplify, lady.
Oh, right.
And
Right.
the sign as well seems incorrect. Where did you get the
No, the sign's right.
right? Let me check.
Because if you move it to the other side, like
Okay, I understand, but let's see. Discriminant is less than 0 imaginary roots, right? So b square minus 4ac.
9 plus 24a.
Wait, I got the answer for the third one.
What is the answer, ma? 24.
9 divided by negative 24 is greater than a.
Yeah, you have to simplify. I also did simplify.
Please simplify. Please simplify that, right?
Yeah, oh yeah,
Yeah.
3,
Negative 3 over 8.
8, yeah,
Correct.
negative
Correct.
3.
Then answer is definitely wrong in the booklet, whatever I'm referring. Yeah, we are only right. Okay, one last question can I give you? I think all of you are in the role. Okay. I don't want to waste much of your time. Okay. Let's see this one. Just answer this. Let it be a discussion question. Okay. Let it be a discussion question. Okay. I think everybody got it. Minus 3 by 8. Yeah, A is less than minus 3 by 8. Very nice, guys. Okay. Let's make the last question very nice and easy. Assuming B is not equal to 0, does the sign of B affect the discriminant? What do you all think?
Yes.
Yeah.
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 Is there any person who says no? Whatever your answer is, you have to defend yourself. Okay, so everybody says sign of B affects a discriminant.
Yeah.
Yeah.
Can you defend yourself? One of you defend yourself. How come? Let me understand how sign of B affects a discriminant. Why do you think it affects the discriminant? Yes,
If,
Riti. Go ahead and defend yourself.
if it's like less than 0, then it's gonna be like an imaginary number. But if it's greater than 0, it could be a perfect.
They're asking for the sign of B. Sign of B is
Oh,
this.
this.
Oh.
You have to be very careful.
No.
Sign of B is this. They are not asking about the sign of discriminant.
Oh.
Assuming B not equal to 0, does the sign of B affect the discriminant?
Oh, so
No.
like if it's ax squared minus bx plus c or ax squared plus
Plus
bx
BX plus
plus
C.
c.
Yeah. Will that affect the discriminant value?
Oh,
I don't think.
Each of you can have different answer. Let's see.
no, I
Why?
don't think.
Why?
Or wait, it's the sign of the value.
Okay. Let's say I have another equation. AX square minus BX plus C. What will be the
I don't think it does because like when you square them, they become positive.
Exactly. In this case, I'll put plus B the whole square because B is positive.
It becomes positive both sides anyway, so
Okay,
it doesn't
again,
matter.
I'll put minus B the whole square. Since it is squared, it does not matter. It's going to be B square minus 4AC only in both the cases. So the sign of B does not affect the value of the discriminant because in both the cases, you're going to square it. So the sign does not matter at all. Any questions? Any questions? Okay, sorry for the 10 minutes delay, guys, today. We will see next week, but I cannot give homework from the book yet. I'm going to give you my assignment based on discriminant and what? Discriminant quadratic formula. Using the quadratic formula, how to, it will be a worksheet. Please do every problem. Then only you will get used to doing it with quadratic formula. You will end up with rational roots, irrational roots as well. Okay, but I will not give you imaginary roots. Okay, then some problems on discriminant. Any questions for me? Stay. Otherwise, we'll see you all next week and I will assign the test. Whoever wants, take the test. It's okay if you don't take the test.
Okay, bye, Auntie.
Bye.
Bye.
Thank you.